This video covers section 9.4, simplifying radical expressions using properties of radicals. Objective 3, use the quotient property to simplify radical expressions. The root of a quotient behaves just like the root of a product. We said the nth root of A times the nth root of B is the nth root of A, B, and vice versa. Well, the same thing occurs for division. The nth root of A divided by the nth root of B is equal to the nth root of A divided by B. And again, it's justified by remembering that the nth root of A is an exponent of A to the 1 over n. When we have a quotient which each of them has the same exponent, we can place it as a quotient all to that same exponent, and then remember that 1 over n is the nth root of A over B. So when I see the square root of 24 over the square root of 49, I think of that as square root of 24 divided by square root of 49, and square root of 49 is 7, and the square root of 24 has a perfect square factor of 4, which leaves an odd 6 out of there. So the square root of 24 is the square root of 4 times the square root of 6, which is 2 square root of 6. Cube roots. I take the cube root of the numerator, cube root of the denominator. The denominator is a perfect cube, so I get 3. The numerator has an a cubed in it. 3 divided by 3 is 1, so the a comes out. And the 5 is not a perfect cube, so it stays underneath. Letter C, fourth root. We'll take the fourth root of 5y to the fourth, divided by the fourth root of 16z to the fourth. 5 is not a perfect fourth power, so it'll stay underneath. But the y to the fourth, 4 divided by 4 is 1. The denominator, fourth root of 16, is 2. And z to the fourth, 4 divided by 4 is 1, so all of those z's come out. And here are 3 practice problems for you to try. I encourage you to press pause on your video and work these out, and come back when you're ready to see the solutions. Now that you've had a chance to work these out, I'll work these out with you. Here, our denominator is a perfect square, and the numerator is 9 times 2. Square root of 9 is 3 times square root of 2 over 5. Here, our denominator is a perfect cube, cube root of 8. The numerator is also a perfect cube. Cube root of 27 is 3. Cube root of p cubed is p. Cube root of 8 is 2. Fourth root of the numerator, 3q to the fourth, divided by fourth root of 16. 16 is a perfect fourth power. It's 2 to the fourth. So 16 is 2 to the fourth, so fourth root of 16 is 2. Fourth root of q to the fourth is q, and the 3 is going to have to stay underneath as the fourth root of 3. Example 8. Simplify, assume that all variables are greater than 0. So here the quotient's already been split for us. And we want to go ahead and put these back together before we simplify. And the reasoning for that is because 24 and 6 have a common factor of 6, which leaves us with 4, and a cubed divided by a is a squared. And now we take the square root of 4, which is 2, and the square root of a squared, which is a. Letter B, we take the cube root of 54a over 2a to the 4th. And now 54 divided by 2 is 27, and a over a to the 4th leaves us with an a cubed in the denominator. Cube root of 27 is 3. Cube root of a cubed is a. Letter C, we put everything under the same cubed root. Negative 375x squared y divided by 3x to the negative 1 y to the 7th. 3 goes into negative 375, negative 125 times. The x to the negative 1 goes to the top and makes an x cubed. And the y over y to the 7th becomes y to the 6th. Now we have a bunch of perfect cubes there. Cube root of negative 125 is negative 5. Cube root of x cubed is x. Cube root of y to the 6th is y squared. And here are 3 practice problems for you to try. I encourage you to press pause on your video and work these out, and come back when you're ready to see the solution. Now that you've had a chance to work these out, I'll work these out with you. We have the square root over the square root, so we make 1 square root. 12 divided by 3 is 4. A to the 5th divided by a is a to the 4th. Square root of 4 is 2. Square root of a to the 4th is a squared. Letter B, we write 1 cubed root over the whole thing. And now negative 24 divided by 3 is negative 8. The x, the negative 1 goes to the top as x cubed. Cube root of negative 8 is negative 2, and the cube root of x cubed is x. Letter C, we write 1 big cubed root. (250) divided by 2 is 125. A to the 5th divided by a is a to the 6th. And that b, the negative 2, is going to go to the bottom as b squared times the b becomes b cubed. Cube root of 125 is 5. Cube root of a to the 6th, 6 divided by 3 is 2, so they all come out. And b cubed, cube root of b cubed, 3 divided by 3 is 1, and we're just left with the b. 5a squared over b. This concludes the video for section 9.4, simplifying radical expressions using properties of radicals. Objective 3, use the quotient property to simplify radical expressions.